Okay, so for this video, we're going to talk some of the prerequisite concepts that you're going to have in the prerequisite homework assignment so that you're prepared for the quiz on the prerequisite. So in this video, we're going to talk about estimating, solving equations and inequalities, absolute value, systems of equations, exponent rules, and polynomials and operations. We're going to have notes in this presentation, and then in future ones we're going to make some example videos and stuff to work through stuff. So going with estimating, the first thing we need to know is estimating means to roughly calculate. The whole purpose of estimate is you want easy numbers to work with. So you're going to get close to the actual answer, but you're going to be able to find it really quick because you're working with numbers that you really like and that you know the facts with. So your steps are you're going to round the numbers. You're going to find numbers that are close to the problem that are nice to work with for that particular problem and situation. So having a bit of number sense is going to help you with estimating. Then you're going to do your calculations, and it should be quick because you're working with numbers that you like. And then you're going to see if your estimate seems reasonable. Does it seem logical that you're kind of close to your answer and looking with that? So estimation often gets confused with rounding, and rounding is where you find a number close to the actual answer as well. But you're doing it a different way, and it's more close. It's going with just a change of orders. So estimating, you're finding numbers close to the problem first, and then you're calculating. Rounding, you're calculating first. So you're working with those ugly numbers if you need to, and then you're finding a number close to the answer. So estimation should be fast and quick and easy, and it shouldn't take a lot of work. You shouldn't need a calculator at all for estimating because you're stuff that you're doing in your head with numbers you like to work with. All right, so then solving equations and inequalities. Your whole goal, whenever you're solving an equation or an inequality, they work the same way. There's an extra rule with the inequalities, but we'll get to that at the end. Your whole goal is to get the letter or the variable alone on one side of the equation or the inequality symbol. So works the same way. You want the letter on one side, you want the value that it's worth on the other side. Your steps are always to simplify each side of the equation or inequality as much as you can first. And to simplify, you're always using the order of operations. And if you don't remember, they are the PEMDAS or PEMODAS, as I like to say, which is you're doing the parentheses first or any grouping symbols. You're doing exponents. And then the next step you're going to do is multiply or divide, whichever one you come to first as you're reading from left to right. So you might have to divide before you multiply. In some instances, and then you add or subtract from left to right as well, and then you combine like terms, get it down to as simple as you can, so there should be one of each term on each side at most. And then you're going to move the letter terms to one side of the equation and the number terms to the other side of the equation or inequality. And then when you're moving things from one side to the other, you're always going to do the opposite operation. So if something was positive, you'd subtract it. If it was negative, you'd add it from both sides. And then you're going to get the variable completely by itself. So if it has a coefficient, which is a number in front of it, you're going to divide both sides by that coefficient. It might be a fraction, so you might be dividing by a fraction, or you can multiply, that kind of stuff. So you have to remember your rules of how to deal with numbers when you're looking for that as well. If you have an inequality, the one thing that you have to remember, and this is the only thing that's different for an inequality versus an equation, is if you multiply or divide both sides by a negative number, you have to turn the inequality around. So in that last step, if the coefficient on the variable was a negative, you would have to, as you're getting rid of it, switch the inequality around. Okay, so then absolute value. Now, the absolute value are those two big sticks that kind of look like goalposts, and you have some value or an expression inside, and that absolute value is always a distance, so it equals the number of spaces. So it means absolute value by definition means the distance from zero, so I like to think of a number line. And you got to remember, distance is a measure. It's something you physically have, so it can't be a negative number. Distance is an actual thing. You can move in a negative direction, but you can't move a negative number of spaces or a negative distance. So that's how a lot of people oftentimes think, oh, it's absolute value, it's always positive. It is, but there's a little bit more to it, and especially when we're dealing with equations or inequalities with absolute value, we have to use that distance from 0, and that number that it's on the other side is a distance. So if you get an absolute value all by itself and it equals a negative number, there's not going to be a solution. If it's an inequality, you have to think of the cases of, is this always true or is this never true? So that gets a little bit more complicated, but we're going to talk about that later in the semester. All right, so when you're solving or simplifying an absolute value, your goal is to get the absolute value, the two sticks, alone on one side. You're going to do it the same as you solve for a variable or an equation. You're just going to pretend like that absolute value is your variable. You're going to get it all by itself. Follow your steps of solving for a variable. And then you're going to make two problems using the distance. Once you have that absolute value all by itself, you're going to think the way that I do it. I think of a number line. So I want it could be negative from 0, or it could be positive from 0. So I'm thinking of those two numbers where it's going to be negative goes to the left, positive goes to the right. So I'm thinking number line space. I write the smallest numbers, I write those numbers, and then in the middle of those numbers that I have, I write the value or the expression that was in the inside of those absolute value symbols, and then I keep the same symbols that I had from the problem, and then I make my two separate equations. So my two separate equations are going to be the left number or value, number of spaces, the symbol, and then the stuff that was in the middle. And then my second equation or inequality is going to be the stuff in the middle, the symbol, and the positive value or number of spaces. There's a whole bunch of other ways that you can create and solve absolute value problems. I just find thinking of the number line and using the same thing is less to memorize for me, and it works pretty easy when I'm looking at stuff. We will show examples of these as we get through problems, and then your last step is always to solve each problem. So you're going to have two different values. It's very common to get two different values for each solution. Occasionally you'll get the same ones depending on the type of problem that you're working on. So absolute value, it does have a lot more steps. It is a distance from 0. It is not always, oh, I have an absolute value, it's positive, and then the other one is negative. That doesn't always work. You have to do a little bit of solving first. All right, so then notes on systems of equations. Systems of equations, what we're going to do in this class is going to be two equations and two unknowns. You can do systems of equations that are more equations and more variables. Unknowns just means a variable. So our goal is always to get the equation with just one variable and solve for it, and then repeat to get the other variables. So you can only solve for one variable at a time. There's a couple ways to do it. In other classes, we could do 3 equations, 3 unknowns. The one thing that you need to have is you need a unique equation for each variable that you have. Otherwise, you can't solve the system. All right, which is what it says right there. And then we have options. There are 2 essential options. One is elimination and one is substitution. So the first way I like to do is mathematically, the elimination will carry you further and you'll get more, be able to solve more problems. So I like to have that as my first option. So in that case, you're going to line up all the parts of your equations. You're going to have your x terms, your plus or minuses, your y terms, your equal signs, and then your constant numbers, or whatever order that you have it in that, but you have to line up each element. And then you're going to get the coefficients of one of the variables to be opposites. You want one to have like a 2 and the other one to have a -2. You're going to do that by multiplying the entire equation or equations by a value. And then you're going to combine, which I do add down because I have an opposite. You're going to get one of those letters to disappear. And you should have an equation or an inequality, but usually an equation, that's just going to have one variable, assuming we started with 2 equations and 2 unknowns, which is what we're going to do in this class. And then you get to solve for that one letter. Once you have that number, that letter, you're going to plug it into one of the original equations, and then you get the other variable. The other way that you can solve systems of equations is through substitution, meaning you're going to solve one of the equations for one of the letters to begin with. Generally, I only do this if I look and I see one of the letters does not have a coefficient and it would be easy to get by itself. However, that works really well in the elimination as well, because I can just multiply it so it's the opposite of the one above it. And then once you have that equation where that one variable equals something else, you're going to take that something else and put it into the other equation, and just simplify and solve for the letter that you have. And then you get to solve it, and then you plug in the answer for that other variable into either equation, generally the one that had the letter solved for, and then find the other variable. All right, exponent rules. Honestly and truly, this chart, you can find it pretty well anywhere. It gives you all the rules. Basically, what you're thinking of is with exponent rules, we have specific rules of how we're going to do it, but we need to know what we're dealing with. So with an exponent, with any term, you have, so my generic term is nb to the x. If you notice that exponent is only attached to the b, that's important. If I wanted it to be attached to the n and the b, I would need parentheses around the n and the b. So when you're dealing with exponents, a lot of times it's very important to pay attention to what it's attached to. It will change throughout the semester, and then you have to think, well, the rules are still the same thing, but you just have to think of a little bit more details because you have more stuff in those attached to the exponent. So the b is always considered the base. It is what you are multiplying by itself, however many times. That's what exponents mean. The x is the exponent, so that's telling you how many times or how many b's you want to be multiplying together. Exponents deal with multiplication. The n is your coefficient, so that could be a number, a letter, but it is not attached to the exponent. It is not going to be multiplied until the end of when you're simplifying stuff. So the product rule means I'm multiplying two bases with different exponents, and if the bases match, I can multiply things and add those exponents. Quotient means I'm dividing. And generally what I think of when I'm dividing is I want to say, where is the higher exponent? And then I subtract. If I am talking variables, it always would be the first or the top divided by the second. So thinking about that, so one thing that I do like to remind people of with division is division can also be written as a fraction. So this would be the same thing as a to the m divided by, that's just the same symbol as a to the n. If you think about it, a fraction does look like a division symbol because you got the numerator on top, you got the line and the denominator on the bottom. So they are the same thing. And this is where I always say, if I had more on the bottom, I would subtract on the bottom and leave the terms, the answer in the bottom. So this could look like 1, because the a's are going to cancel out, a to the n minus m, if the exponent on the bottom was bigger. So we're going to deal a lot more with exponents throughout the semester, and we are going to deal with negative exponents as well. So power of a power rule means that I have an exponent inside parentheses and an exponent outside parentheses. So everything in that parenthesis is going to need that outside parenthesis, that outside exponent. It's like distributing two exponents. So if I gave you something like 3a to the m all to the n, everything would get that exponent. So it'll be 3 to the n m to a to the, sorry, a to the m n. So m, yeah. So we're multiplying with that. Power of a product rule is the same thing that I'm showing with my example. So everything gets that exponent. You would be multiplying with those exponents. They're assuming that the exponents currently are ones. Power of a quotient rule, that means I just have a fraction or a division. Same thing applies. Everything inside the parentheses is going to get that exponent, and then I'd simplify from there. The zero exponent rule. This is very important. Any number that I have or any term that I have, if it does not have a coefficient, there is a hidden 1 here. So what this means, a to the 0, means I have no a's, but I still have its coefficient. So that's why it's 1. A to the 0, n to the 0, 5 to the 0, anything to the 0 power is always going to be 1. It's one of those rules you should just memorize. Negative exponent rule means that I have, I call it the hidden fraction rule. If I have a negative exponent, it means whatever the base I have is a fraction, and the base that I have is in the wrong part of the fraction. It's not happy with where it is. So really, if I'm thinking about this, this would be a over 1 because any number can have a denominator. Any number can be written as a fraction. And what it's saying is this a to the negative m, it's not where it wants to be. It wants to be in the bottom. Remember, we still have that coefficient of 1. So if I put it where it wants to be, it becomes a positive and happy number. Easier thing to think about it is if I have 2 or n b to the negative c, this would be the same thing as that negative c is only attached to the b, so that n stays where it is. The b is in the wrong spot of the fraction, so this would become b to the c. All right, and then fractional exponents really just become a square root. We are going to be talking about that a lot later as well. The denominator, the bottom of that fraction, goes on the outside of the square root or the radical. It could be a 3, it could be a 5, whatever it is. The numerator, the top of that fraction, stays inside the radical. So we're going to talk about those when we're looking at it a little bit later. I'm going to save this picture. And then I'm going to delete all of my drawings. Okay, and then we are going to go to the next page of the slide, which is my polynomials and operations, and then hopefully we will be done with this video. So looking at that, polynomials and operations, we're going to be talking with terms. Terms are any mixture of letters, numbers, exponents, that kind of stuff. So in this case, I have the term n, which is my coefficient, b to the x, which is a base and an exponent. So I have xb's, d to the y. So looking at that, and when we're looking at terms, like terms are going to be terms that have the same bases and the same exponents on those bases. We don't care about the coefficients because we're going to deal with those, but like terms have to have the same bases and the same exponents on each one of those bases when we're looking at it. So if I have m, b to the x, d to the y, my base b has exponent x, my base d has exponent y. These are going to be like terms. It doesn't matter that my coefficient has changed from an n to an m. They'd be things that I would be able to add or subtract with. Multiplying and dividing, I can do that with anything that has a single term. All right, so then if I'm looking at n to the b, y, d to the x, this isn't a like term because my base b has exponent y and my base d has exponent x, and the exponents have been switched. So that is not a like term. I would not be able to add that to that first term that I have, that n, b to the x, and d to the y. All right, so looking at this, polynomials are just many-termed expressions. Now, the one thing that I forgot to put in here, and I will be adding it in the notes, so if you're looking at the slides later, they're going to look a little bit different. The sign, the positive or negative that goes in front of is always attached to the coefficient. So it's one of those things that you have to think about with it. It is always, if there's a positive or a negative, that is going to be part of your term. And terms are anything that is separated by a positive or negative. Polynomials are many-termed expressions. So a binomial means we have 2 terms. Trinomial, 3 terms. We can go further into it, but for the most part, we're going to be working with binomials and trinomials and monomials, which are just single terms. All right, standard form of a polynomial. We have a bunch of different standard forms, but if I'm talking a generic standard form of a polynomial, we are talking, we want the terms to be in order so that everybody would be able to figure out what we've got, and they're a little easier to work with in a lot of cases. And for the standard form of a polynomial, we want our terms in order with the exponents, which is also a way that we call the degree of a term, counting down. So if I and then when we're adding and subtracting, I'm going to come to that in a minute. So if I give you the polynomial 5b squared minus 7b to the 4th plus 2b to the 8th minus 3b to the 6th, I have 4 terms here. The terms are, this is one term. This is my second term with the exponent. This is my third term. and this is my fourth term. So if you notice, I do keep the signs with them. This is a generic, generic general polynomial. I just have four terms looking with that. If I wanted to be in standard form with the exponents counting down, I want the term with the highest exponent first, which is the 2b to the 8th. Since it's starting with a positive, we assume things are positive, so I don't need to put that plus 2b to the 8th at the beginning. And then my next highest exponent is a 6, so that's why I have the minus 3b to the 6th, so the sign went with the whole term. And then b to the 4th is my next one, so that is my negative 7b to the 4th, and then I end with my 5b squared. And remember, if there is no sign in front of something, we assume it's positive because we like to assume the best out of things. All right, so this is a standard form. We've got plus or minus as part of the coefficient yet again. And then the lead coefficient is that very first term that we have, in which case my degree of this polynomial is based off that lead coefficient. So my degree is 8, and my leading coefficient, that first coefficient, is a 2. If it was negative, it'd be a negative 2, but it's a positive. Now, when you're adding and subtracting with polynomials, you have to remember you can only combine like terms, meaning those bases and the exponents on the bases have to match. And then you get to just add or subtract the coefficients, and the rest of it stays a like term. So you don't change those bases and the exponents. When you're multiplying, you get to multiply any polynomial, can be multiplied with any polynomial. You just have to remember distributing, and a lot of times we'll be doing foiling. So everything, if you have multiple things, multiple polynomials multiplied, we have to use stuff like FOIL and all that stuff. We're going to do that in some of the problems. Just remember, when you're multiplying a monomial and a monomial, it is multiply the coefficients, and then you add the exponents that have the same base from the two terms. And then you make it into a single term. It probably won't be a like term to any of the beginning problems, but you might have like terms later. So that is an overview of quick notes of a lot of the concepts that we have in the prerequisites stuff. I do have notes for some word problems that will be in a separate video.